Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video, which I will give you a trigonometric equation that models some real-world data, and we'll answer some questions about it. So let's look at this example. Average maximum temperature in a city modeled by this trigonometric equation. Of course, it's trigonometric because of the cos here. So X is the number of months after January 1, Y the temperature in degrees Celsius. So what I'm going to do is I'm going to graph this function here, and that will help us understand a bit more about what's going on. So we're already familiar with graphing many trigonometric equations. So let's just find the features and then plot them. So of this graph here, we know that this number here by itself, like outside of the cos function, that is the mean position. That's what I've been calling it. So the mean position of this graph equals 20. So the maximum value that y can take, the maximum value of this graph, it always occurs when the sine or cos equals 1. So we remember cos of anything just by itself always lives between -1 and 1. So the maximum occurs when this equals 1. So y will be 6 times 1 plus 20, which is 26. So similarly, the minimum value of y in this graph will be when this equals -1. So y will be 6 times -1 plus 20, which is 14. And we'd expect that answer because the mean position is halfway between the minimum and the maximum. And we also expected that value for the minimum because this number here in front is the amplitude. So the amplitude of this graph is 6. Remember, that's the distance from the minimum to the mean position or from the mean position to the maximum. So the last thing that we've been calculating is the period of the graph. So we should be able to tell just from the fact there's a pi here, this is in radians. So remember, the normal period of the cosine graph is 2 pi. When you have something in front of x, you divide by that something. You divide 2 pi by that something to figure out the period. So the thing in front of x here is pi over 6. So you could put this straight on your calculator and you get that the period is 12. So remember, that's the distance between peaks. So let's now put some numbers on our axes and graph this. So let's go ahead now and graph this. So don't worry about the scale, this is just a rough sketch. So because this is a cos graph, we just need to remember cos always starts at its maximum, whereas sine starts at the mean position. So it will start here. Now, if you didn't know that, that's fine. You could simply substitute in x for 0 and put it in your calculator. You would get 26. So because we figured out that the period is 12, that means that it will next reach this peak over here at 12, and it will reach that peak over here again at 24. So from what we know about the behavior of both sine and cosine graphs, we know that the first minimum will occur halfway between these two maxima here. So the first minimum will occur at x equals 6, and we'll put it down there. Now the period of 12, which we figured out over here, that's not only the distance between maximums, it's also the distance between minimums. So the next minimum will occur at x equals 18. So we probably have enough here to draw the graph. It will go down from its maximum, go up, down, like that. Okay, so that is the graph of this up here. So what's happening is at January 1, that's the hottest part of the year in this city, so it could be a city like Canberra. So the temperature then steadily declines down to 6. So 6 means 6 months after January 1. So this would be July 1. Then the temperature goes up again to 12, which would be January 1 the following year. Then it goes down to a minimum of July 1 the following year, and so on. Keeps going up or down. The maximum is reached every January 1, and the minimum every July 1. So I'm going to get rid of this over here. Please pause and copy it down if you need. So let's answer these questions here. So what would be the mean temperature in the city? Well, that would just be the mean position of this graph, which is 20 degrees. So that's a really easy question. So it's degrees Celsius because we said y was in degrees Celsius. So now we look at what is the average temperature on May 1. So we're looking at how many months after January 1 this is. So when x equals 1 month later, that's February 1. 2 months later is March 1. 3 months later is April 1. And 4 months later is May 1. So May 1 means 4 months later, x equals 4. All we have to do is substitute x equals 4 into this equation here. So if we put that into our calculator, we just simply get y equals 6 times cos of 4 pi on 6 plus 20. And that just gives us the answer of 17 degrees Celsius. So that will be the average temperature every May 1. So it'll be like down here 17 degrees, and then it'll reach 17 degrees next year on May 1. So interestingly, it will reach that 17 degrees on May 1. It'll also reach over here every year on September 1. And that's because if I were to substitute over here x equals 8, I would get the same value of 17 degrees. All right, let's now do a question where we know the y value and we have to find the x value. So let's answer this question here. So we're saying in which months is the average maximum temperature 23 degrees? So the average maximum temperature is y, because we're talking average maximum temperature. So all I do is I substitute in y equals 23 into this equation here. So you've had some experience solving equations like this. The first thing I'm going to do is subtract 20 from each side. So then I'm left with 3 equals cos pi on 6x. I now divide each side by 6. So remember, when you're down to just cos of something, you take the cos inverse. So if I take the cos inverse of both sides, cos inverse of a half on the left-hand side, if I take the cos inverse of this side, I'm just left with what is in the brackets. Now the cos inverse of a half, remember there are a few different answers. Because this is in radians, we want to give those answers in radians. So for cos inverse of a half, remember there's one that's 60 degrees or pi on 3. So that's one answer to cos inverse of a half. So then we'd have pi on 3 equals pi on 6x. So the other example between 0 and 360 degrees is 300 degrees. Or in radians, it's 5 pi on 3. Cos inverse of a half also equals 5 pi on 3. So that's the next solution. So then 5 pi on 3 equals pi on 6x. So for both of these equations, all we need to do is divide by what's in front of x. The way we undo timesing by pi on 6 is by dividing by pi on 6. So we just go pi on 3 divided by pi on 6. So if you put that in your calculator, pi on 3 divided by pi on 6 is 2. So x equals 2 is one solution. Now if we do the same here, 5 pi on 3 divided by pi on 6, we get the solution that x equals 10. So remember that x was the number of months after January 1. So 2 means 2 months after January 1. So the first solution 2 months later is on March 1. And 10 months later, we'd be in the 11th month, November. November 1 will be the other time. So the average maximum temperature of 23 degrees in March, November. March 1, November 1. That's our answer. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.